In this episode, I have a conversation with Andrew Kelley and Ginger Bill. Andrew Kelley is the creator of the Zig programming language, and Ginger Bill, the creator of the Odin programming language. Both of them fill a similar niche in the C-like space with lots of modern sensibilities built in. And the reason I wanted to have them both on together is because I'm quite interested in exploring alternative paradigms, but I want to make sure not to lose the lessons that come from that first iteration. And so I wanted to get two different sort of similar perspectives on the best of the C-like paradigm, and I thought that the two of them might have similar but unique perspectives on that particular topic. The conversation becomes pretty much a back and forth from the beginning. They ask me questions about non-textual programming approaches that I'm interested in. I ask them questions about their projects, and other things get explored along the way. The primary theme here, I would say, became the boundaries of programming languages. Things like the significance of the text file as a data structure, the significance of the keyboard as an input device, the significance of language design as a piece of the interface for creating software, the importance of different pieces of the toolchain and how difficult it is to get off of them if you want access to low-level hardware, and other things along those lines. It's not a particularly organized conversation because it's so much of a back and forth, but it does touch on a lot of interesting topics, and I, for one, learned a lot, and I'm very grateful to have had the chance to pick both of their brains. If you get something out of it, then I'm glad to have been able to share this conversation. And so now, I hope you'll enjoy. All right, I'm here today with Andrew Kelley and Ginger Bill. Thank you guys for coming on.
You're welcome. How's it going?
Yeah, thank you very much.
It's going pretty well. I'm excited about this conversation because today I'm going to have you guys try to disabuse me of some of my ideas about how textual programming isn't a good use of time. And I think a big thing I'm very interested in is like new kinds of programming, where I don't have a lot of fun sitting in front of a text file all day, and I think about other ways that like very serious native programming might happen that doesn't look like that. And so, since you guys are both authors of classical textual programming languages, I want you to kind of show me where I'm missing the big advances that are still available by just improving over textual languages. So, I think a good place to get started with that is to kind of outline what was your idea of what it meant to be building a programming language. And it's kind of a big, broad question. So I've thought of a couple of simpler ways to zero in on what is useful about the language space and iterating inside that. So when we think about the modern pipeline of writing software in a classical way, we have a text editor where we make text files and a compiler which implements some language, but there are sort of boundaries there. The compiler doesn't get to redefine what text file means, or on the other end, what an executable file means. So the compiler has to play by certain boundaries on either side. And so I'm curious, what do you think the big, this might be a question that is hard to answer. What are the big things that you can have control over in that segment? What are the issues at play when you pick one language over another?
Well, I think the first thing I would want to ask is when you use these non-textual programming languages, what does your output look like? Are you still producing binaries that run on, for example, Windows, Mac OS, Linux?
Yeah, that's a great question. So the classical way that a lot of non-textual programming systems work is that they go into some kind of an interpreted environment or something else like that. They get, you're targeting a bytecode or something, or you're building your own runtime. So you're simulating the system within, you write some maybe native code or something along those lines that then runs the virtual machine that is then targeted by the higher level, whether it's node and wire visual programming or other things like Scratch is an example where it's non-textual. You don't write a text file, but it just transpiles into a JavaScript file. So it kind of maps into an existing architecture. And so really anything is an option. What I'm interested in is writing native programs. I mean, I'm interested in going all the way to the point of saying like, hey, I'd like whatever is an option in C-like languages to be an option. That's less common.
So all I was going to say is this one thing I wanted to comment on earlier. When you brought up Scratch as a visual programming thing, to me, Scratch is still a text-based thing. It is literally still just text where you drag and drop the identifiers and the control flow. At the end of the day, it is one-to-one with a normal text editor. And I wouldn't. And the other thing I want to say about visual programming for other people listening is that it's not just hey, this is the visual programming language, but it's visual programming stuff like tools even built on normal languages today. So again, a debugger is a very basic example of this. But you could also have other type of debuggers like Whitebox, I know from a friend of mine, Andrew Rees, where you can actually, it's kind of a debugger in time. So you can see the progression of how that data moves and operates and such. So it's another way of just visualizing your programs. To go back to the bit you were saying about text files themselves, one thing that popped straight into my mind was thinking about Odin and also how Zig how they do their, let's call it, package or module system. Odin's approach is we said, look, there's a file structure on pretty much every computer you can use, and it's hierarchical. It's called a directory, and it contains files and other directories to keep it more generic, yeah? So why not use that? So in Odin, if you have a directory, that is your package. And if you have .odin files within that directory, they are part of that package. All those files can see each other inside and out. So then you can then organize by the file. The Zig approach, and please correct me if I'm wrong, Andrew, is the file itself is the thing that you import, and a file is technically a struct. So when you, because in Zig, a namespace is a struct, right? There's no separation of this. So this is very similar to back in the day before C++ had namespaces, that you just used a struct to do it. So it's that kind of unification there. So clearly we did two different approaches to this, but we were kind of like, hey, why don't we just kind of use the file system that already exists there to have this kind of structure? Odin's is very, very hierarchical without any cycles, so we don't allow any cyclic imports. Zig, from what I understand, does actually allow for cyclic imports, because it's also lazily type checked as well, which is why it can allow it. Well, Odin's very, when I say lazily type checked, I don't mean Haskell, I just mean it only type checks when it uses it, when it comes across like through the type checker. Well, in Odin, it's very much like, well, if it sees it, it type checks it. Pretty much, not just when it comes across it, if it's there, it will do type checking. So it's a bit more of a different approach. But those are kind of like, hey, this is why we've used text. But back in the day, if you look in C has only one file. Fundamentally, it's just pasting all these different tokens through the includes to be giant. It should just be one giant file. So really, it isn't really a file anymore. It's just a giant token stream. So even those like C and C++ don't really have a notion of even text files, really, at the end of the day.
Yeah, to add to your point there, just yesterday I was working on the LLVM 18 upgrade in Zig. And part of what I have to do is maintain a C API layer on top of the C++ Clang API layer. And the way that I do this is with a whole bunch of static asserts in a CPP file. I just basically copy every enum and then assert every enum value so that I can detect when it changes and then update my bindings. And what I have to do when it fails is I take the failing compiler command and I append -E to it so I can look at the pre-processed output, and I just go find the enum and then I paste it and edit it with Vim. But it's always like millions of lines, like you were saying. Like it's one file, right? Like the C++ thing, it included the entire universe, and then I have to go find like where that one enum is in that giant file.
Yeah, it's kind of insane when you think about it. And this is where something like, if you weren't dealing at just the one file, giant token tree file, and not even that, you weren't even just working on with text, but actually at the AST level itself. That's what, again, I know you would experimenting with Dion back in the day, Alan. Then yes, things get a little bit, well, a lot nicer to deal with.
Yeah. So it's interesting that you brought up the module system, because that was actually like one thing I've never done in any language I've used is had a module or package system in the language. Like I've only ever really done the C++ thing of module is in your head, and what's actually happening is you're using the preprocessor to paste text files together. And so that is like the depth of my understanding. Like it's literally in my head the case that I'm like, well, you could build a language, a text language, where the idea was you're just going to have to specify every single source file on the command line every time you want to invoke it, and that way it doesn't need to know about how they link together. But very often that's a bigger pain in the butt. Like putting things on a command line is inconvenient compared to having lines of like import or include or whatever it is on your text files. So we go with that instead. But beyond that, I don't know if there are other problems that are solved by a module system, or problems that can be avoided by not overcomplicating the module system, that are worth knowing about.
If I may bring the conversation back a few places earlier, there's something that has just been nagging at my mind here.
Hmm.
So I want to really understand what you're trying to do with non-textual programming, because when I think about what a computer's doing, I feel like I can draw a line from like machine code representation all the way to a textual source code. And at some point on this line, we diverge in our ideas of where like semantic compression makes sense to apply. And let's try and find that point, you know? If we have x86 code, that's kind of what we're kind of stuck with that. Like a lot of people have worked really hard on creating a specification for this, creating hardware that works really well. That's kind of like fixed in stone, if you will, or in silicone. So we have to use that. On the other side of like with source code, we absolutely can change that, but we have to get there. We have to like move across this line. So a lot I want to observe that a lot of constructs in popular programming languages map directly to machine code. So, for example, just inline assembly blocks are actually just one-to-one mapping. And zooming out a little bit, functions are pretty low level. They map pretty directly to code. And I'm curious, if you want to get away from textual programming, how do you reconcile that with the fact that you need output machine code?
Yeah, that's a fascinating question. So I think I don't necessarily assume that text programming has has nothing valuable inside of it. Instead, my assumption is much more narrow to just basically that the choice of data structure, which is text files in a file system, has certain limitations that can very easily be imagined away, but it's hard to imagine away other things. Like if Bill brought up the Dion experiments from a few years back, and something that I learned along the way there is like I don't want to edit mathematical expressions in a different way than what text programming came up with. Like you can spend all day coming up with like I'm going to manipulate the tree directly, or I'm going to like drag and drop values that are built out of expressions into bigger expressions. It's like nodes and layers. It's like if you are trying to figure out how to index into an array by figuring out like you've got an X and a Y and a grid, it's like just write the pluses and the times. That is the format that expresses that idea concisely. And what I think is interesting is that is where text is as far away from the output as it can be, right? In the things that you pointed out, procedures, very similar to procedures and functions in text languages, map right onto what the assembly is going to look like. But when you look at what is a mathematical expression, like pluses and times, the arithmetic, that is an expression that goes through more interesting reformatting to get into the assembly. And I think that is one of the strong suits of text. And so I'm like, why would I want a non-textual programming language where I didn't have the option to use text for my expressions? Because that seems to be the best thing going for arranging expressions that I can find. But there are other things like choosing names on identifiers where I wonder if this is a problem we always are going to have to live with, or if there's a simple data structure that is got the ability to go out to a text expression to get something like something like arithmetic done, but that can also utilize other features of the structure for things like, a struct or a procedure doesn't really need to live in the same text file as the next procedure before or after it, because the compiler's first job is to figure out where the boundaries are between these things and not think of them as really living in the same space, but as being these nodes. And so if the compiler is already throwing away that part of the text, then maybe there are things that are richer, like the text's strong suit, like I said, is this expression compilation. Maybe there are other data structures whose strong suit would get you farther away from what the assembly looks like, but that the text file would struggle to sort of uphold that same data structure. Or you can imagine there's basically no data structure you couldn't encode into a text file if you're willing to link it together the right way, but there are points where the maintenance of that in text gets out of hand. And so what pops in my head is like really complicated directed graphs are a lot nicer to edit in a directed graph editor than in a text file. So I don't know, but if there are some kinds of programming where directed graphs are a nice data structure to edit directly, that would be the kind of thing I would want to be able to fuse them eventually. But I just say non-textual as in literally meaning getting away from the text file and file structure, data structure as the only data structure that's available.
To kind of get onto that point there, the point you're making here is that you want the input to still be through your keyboard, pretty much. Because at the end of the day, you've got, 10 digits? You can have got much better throughput than going through a mouse with, 2 clicks. So clearly you've got a much better interface to go through that when you know it's much better. And also humans have been dealing with like language like that with symbols, how we type and all on text, since the dawn of civilization. That's how civilization is. We've got written text, we've got all this kind of sort of things. So that's kind of the interface. But the thing you're talking about is, yes, but when we actually deal with compilers, the thing we want to operate on is not the text. We actually want to deal with something like an AST at the end of the day. We don't even just want you have to tokenize it, and the tokens are much nicer to deal with than just raw text. And then we want to actually structure those tokens in some sort of abstract syntax tree. So then we can then manipulate it in a much more useful manner. Something like assembly, even then, that inline assembly isn't technically direct. It's still having to go through the tokenization and then some. I'm going to still call it an AST, technically speaking. It's just very flat. So it's kind of that's what you've kind of deal, and clearly, and what your experience with Dion were doing is like, say, that's actually the thing you want to deal with through your format, how you store it, because you can then query that dead easily. That AST that you're talking about is still not just an untyped AST in the format. You would actually have a completely typed thing, which you could then deal with in all the different aspects of the compiler itself and all the different tooling. So when you clear like, where's this, click on this variable here, and you can see the entirety of how that gets used. So you can then rename it all, more than what just like Java IDEs do, by the way, because they're still working at the text level. It just happens that Java is actually a very simple language to parse in many ways, and how it's all been structured, obviously, is still, again, very file-based. It can just, the IDE knows how to do it. Because again, one of the benefits of Java that other languages don't have, for a very long time, it didn't have conditional compilation. So because it didn't have conditional compilation, there's no conditions for it to stop. It just checks everything, and it knows everything. So when you have, and there's half the problem, is when you have the conditional compilation, things start to go a little annoying. But you kind of need the conditional things if you've got multiple targets, more than just the JVM. But again, just the JVM there's no such thing as just the JVM. There's multiple JVMs out there, obviously. It's not just like the one that's playing Minecraft. There's a JVM on your phone SIM card. Completely different type of thing, but it's very, very still kind of a similar thing. So my view when it comes to like the visual programming thing is you still need a decent core foundation of a language to build on top of that. So the textual thing isn't necessarily, it's like it's just the interactional thing, that's the input. But that AST level of like, actually, what are the semantics of this language are still extremely important. And all of the lessons from the textual programming languages, again, you're talking about the Algol family, the C-like languages, are still extremely important to learn from. It's not just, we could start from scratch. And no, really, we've learned a hell of a lot.
Isn't that kind of a failure of the Java project? Like the whole point of Java is that you run on the JVM, like they could have avoided the conditional compilation, and they could have just said like, no, absolutely not. This is the point of Java.
Well, they kind of do. Most Java projects do not need it. That's the thing. But there are sometimes, it's not even a failure. It's just like, that is actually the case. Sometimes you actually just need conditional compilation. Like even projects I've done where we've just done conditions like, hey, we need debug mode effectively, right? Just debug mode. So we've got some extra things enabled. Now you can do that it can still be technically done runtime evaluated, but sometimes you don't want that in the JVM, actually like the final binary, because the thing about Java things, you can decompile them and see what it looks like. So if you're trying to obfuscate things away, that's one way of doing it. So conditional compilation is more of this is a requirement of what we're trying to do, more than like, hey, can we just run it on the JVM? which is not a failure of the JVM. I would praise the JVM itself, not Java. Oh, God, I hate Java. But I'll praise the JVM quite a lot for other things.
Yeah, that's a good point. I think if I was running the Java project, that would have been a battle that'd be like a hill that I would die on. But I see your point though. I just think
Yeah.
it'd be a really nice simplification for everyone if they just stuck to the rule of there is only one target. Like that's kind of a nice property to have. And I agree that there's downsides like that you just mentioned, but
Yeah.
you could get away with it in that project. That's the difference. Like you
Oh
absolutely
no,
could
you can
not
still get away
with
with it, and the vast majority of like Java programs will do. Another one that's trying to be a VM system is like WASM at the moment. You've got a single target, even though that's technically failing now already because there's so many extensions, because it needed to be extended. They were already doing that. So in that sense, it's not a single target anymore, but it's the virtual target. That's the whole point, which is kind of, again, a good thing for using for. But for me, when it comes to visual programming, it has little to do with the going from like the text to the AST to the checking to the IR to the bytecode to the machine code, whatever, that kind of process. It's more of a, how do I visualize that better? How do I visualize that entire process better? Because we don't. I was just saying, we just don't have a way of visualizing it. No one, like look at compilers. They don't actually give you enough information most of the time. You think, oh, they give you error messages. I'm like, no, I want to know all of it sometimes.
I have some. That's a good segue into a topic I'd like to spend some time on. But I know, Andrew, you were about to say something, so if you'd like to, go ahead.
Yeah, well, just in the last 10 minutes, Bill made some excellent points, which ignited my imagination, and I wanted to point out. Wanted to point out a couple things. So, one is, have you ever tried to cache an AST? Like you think like, ooh, I know, I finished parsing once. Why repeat it? Might as well cache it. And then you do that, and you find out that the cache is bigger than the input, and actually kind of makes sense just to reparse, even for performance, because the syntax of a lot of programming languages is so compact. It actually is pretty well semantically compressed, and I think that is a indicator of the fact that you're actually managing to encode a lot of information with text, and trying to compete with text is difficult, which I think is kind of what you're exploring on this podcast. Is like, it's difficult, so let's explore it.
Yeah, and so that's a good point, and I'll speak to that for a moment. So I think that you're absolutely right that text is very compressed, and that is one of the reasons why it is so compressed, in my view, is because it comes to this idea of like looking at what we're doing is ultimately like you got your text editor and your language and all the different ways you can build theories about what it means to construct this whole tool chain. To me, the root node of the whole thing is an interface for constructing software. It's like the whole thing comes together when all the pieces are working the way they're supposed to. What they're supposed to be is an interface for constructing software. And the reason why it's interesting to talk about text is that's kind of like the front end of the interface. And so there are things like, yes, the text is compressed when you look at what it looks like compared to how you expand it, but it also has to be compressed because the expanded thing would be inexpressible in the text editor. Like in the text editor, each amount of human work, and you can obviously build text editors with fancier features, but before you make it hard, the base case is 1 unit of human work is 1 byte of data in the data structure, right? And so it's not an interface that can really ever transcend that limit except by adding magic spells into the list of commands that you have that do like whole rewrites here and whole rewrites there, which are great, but it's still like makes me wonder, well, what if the base case had different data structure properties where, if I'm building a directed graph, there's some things about that are more painful, and it certainly wouldn't be better to, in my mind, I never want to use nodes and wires to arrange my basic arithmetic and bit shifting algorithms. Like that would just be such a terrible way to degrade my productivity. But if I actually need a directed graph, like if I'm building a state machine and it's got 20 different interesting states that kind of interconnect in different ways or something, speccing that out as a switch in text feels equally like it's in the wrong direction. Like I should really be in a directed graph editor of some kind that can then compile to a state machine. So yeah, I'd like to talk a little bit more about that interface direction, and I think the I'm forgetting now what the great segue was that Bill had. Like you were mentioning something about it, but oh, you guys were talking about like how to visualize. We don't visualize, right? You were saying we don't visualize these things, and I think I'd be really interested to hear more about that. Since you've built programming languages, what are the things you do visualize? I bet that there's some interesting stuff in there that is connecting back to the things I'm thinking about. So if either of you have thoughts about that, I'd love to hear more.
Well, one of the simple things, which, how do I put this? Anyone who's experienced enough languages, this is actually nothing to do with the compiler per se, ish, is more of a, how do I phrase this? Very early on, if you've got runtime type information or compile time information or comp time, if you want to use the Zig term, that is an already extremely powerful thing to have at a language level, regardless of the compiler per se. The compiler generates it, obviously, but the user has this ability to actually just look, I can look at my data, I can even know what the structure of the types it was and its layout, and then from that you can visualize just the data alone. So a good example of this would be, hey, I can just select this, say I've got a game and it's got a UI already, right? Got dead simple UI. I could literally click anything and it will automatically generate a UI for this particular data because it's got all the runtime type information or compile time type information just generated out, magically done. And that's one of those things where that's already a nice little visualization that I've actually got the ability to inspect or reflect or whatever you want the term to use, go back and look at all doing these things. The thing is, a lot of people don't realize you do that. Most people, when they think of it, they just keep their heads in like, it's just for serialization, deserialization, and marshalling, whatever you're going to call that term. And it's just that kind of area, but it's like, okay, now imagine that at every single stage. And not just like at the end. Like, okay, when I'm looking through the compiler, I am looking at things like, okay, where are the slow bits? A really good example of this was the other day at work. Someone, they didn't tell me, but they were like, compile times have got really slow, Bill, all of a sudden. And I'm trying to figure out why. I'm like, what do you mean? And then all I did is I literally got the compiler. I got all my like debug messages on. I went, it's really slow on this file. And I went, oh my good God. And this is one of those things where, Andrew, you were saying is that, but the text is actually more compressed. In this case, it was the exact opposite. So in this case, it was a 20 megabyte array of just bytes. And you've got each literal in there. So each literal is 4 characters followed by a comma. Because it's a hexadecimal as well, it was encoded as. And it's just been generated, someone had. And this thing was taking a long time just to pass and type check. Because it's going through every single literal, making sure it's the correct type and it's correct size and it fits within a byte and doing all this. And I went, we have a load feature, so you could have just had a binary bob and load that in. Yeah, this cut off most of it, already gone. So it was kind of more of the binary format was the better thing to use. And all that the language did was embed the binary file so it didn't have to do any type checking. So there's one thing is like, hey, I wanted tooling. I'm like, okay, where's the slow bit? I want to know where the slow bit is in the compile times. And it was like, okay, it's back to being fast again, which is great. But that was kind of one of those things where like, that's me like, okay, as a compiler developer, but even as a user, there's a lot of things where I'm like, okay, how many instances of this being used? Where are things that are being used or they're being misused or they're being shadowed or there's been like minor bugs? A lot of when you're structuring up a compiler is also just dealing with those issues as well. So they kind of plop out for free, but it's kind of more of we don't really tell the user a lot about it. And that's also just like the error reporting, all that kind of going on. And again, it's just another way of visualizing. Even if that visualization is still in text as an output, it's still something we lack. So just literally one thing that just popped to my mind was C. C's got a lot of undefined behavior, but the compiler doesn't really tell you about it unless you put all the warnings on. And even then, it still doesn't really. So you have to be careful. But then it's like, well, the compiler does know this actually, right? So it's like, why it could report us back to us, even if it's in a very weird thing. If it's an encoded format, you could then make a visualizer to show you actually much better, I think, things going on. It's like, that's why, yeah. So again, it's more of I'm using the word visual in such a more generic term than you were probably using, Alan, or even Andy. So it's kind of more of I just want to get more feedback so I can actually help make my programs better, or even just make the compile times faster, or just make the asset pipeline better, or whatever it is.
I'd like to speak to this topic as well. I think that this topic of, if I can restate the question, it's about when you have kind of hidden state in your software and you want to be able to visualize it or understand what's happening. I think for me, this is kind of like the final boss of my programming experience and skill level. You learn how to do this and that, and you get better, and you learn about not doing object oriented programming too much. You learn about data oriented design, and then for me, the final boss is like resisting the urge to just go down a debugging rabbit hole and waste hours upon hours trying to solve one bug, instead of spending that time creating introspection and exposition of state so that all bugs of that category are instantly solved just by looking at something visual that you can see. And yeah, so for in a compiler or in any software, really, you end up creating these abstractions to solve your problems, and you just got to be able to visualize the abstraction.
Unfortunately, right here is where we experienced some technical difficulties. A few minutes later, we got things back and running, and Andrew picked up from relatively around the same spot, but with no good way for me to fake the transition. So here's where we picked up.
Anyway, to pick up where I left off, one of the biggest challenges for me in my software career is remembering to have the discipline to visualize state and not just try to go down debugging rabbit holes. And that applies to all software, and for compilers in particular, you just want to make sure that all your hidden data structures are not hidden, and they have textual representations where you can display them, debug them, see what's going on. Anytime you do something, it's almost it's like a yin yang thing, because anytime you create a module in your software that's useful, it's useful precisely because it's doing some kind of black box state management that's handy to think about in terms of its API only, which means that when it goes wrong, you need visualizations. You need to expose that state so that you can quickly understand what's going on in the box when you have to understand what's going on in the box. And I think that for me, that lesson has been very difficult to learn.
So I think that I agree with that, and I would like to know what you'd think about taking that a step farther, which is the idea of creating debug visualizations. I mean, in games, that's literally means putting, you make your own little visualizers on top of things. And then in a lot of other cases, it means like you have a log or you have some way of outputting some kind of, getting some signal out from your system for developer mode. In that analogy of, or the framework, in the framework of the compiler and the text editor all come together to form a interface for creating software, what would you think about saying, I think this is kind of where Bill was driving to, that all of that sort of internal visualization really ought to be designed as for the user? Like there should, would that be an insane thing to design around? Or is there, at least in the case of a compiler, it feels to me like the more you spend time with it, the more you start thinking like, well, I wish I understood more. And we have Godbolt as the ultimate example of like, well, all the intermediates are still getting lost, but people want to know what's coming out of their compiler. And it makes me wonder, like, what would a ecosystem look like where you could tap into your compiler and say, like, at this stage, what were you doing, and help me understand more here, and then it could expand that, but like there's sort of a new limitation I'm hitting into of like the classic idea: compiler text file comes in, thing comes out, and if you didn't ask for, the log on a particular stage, you're just going to have to run it again. Or something like this, right? There's breaking the compiler up into those steps and interacting with it fluidly feels very difficult to me from the current paradigm, in similar ways that the text file gives barriers. Sort of the command line text interface also gives an interface barrier that I wonder how limiting that might be in the design of these things. So I don't know what that makes you think of, but I put that forward for you to respond to.
Yeah. So Bill made a really interesting point earlier about 10 digits being more efficient than using a mouse. And I think there's some implications there that we can think of. And it might seem silly at first, but I think it's worth like really thinking about it, because the amount of information bandwidth available to the human body truly is the upper limit of interacting with a programming environment, both as input and as output. So, as far as output, we're talking about 10 digits. Why don't we speak? Well, I think it's because the digits are more digital. Pun is now intended. But the point is that it's the analog speech. There's a lot of information there, but it's almost unintentional information. It's a little loosey goosey. The 10 digits, it's a lot of bandwidth, but it's digitized. But maybe there's a way to try to capture that extra information in a way that's still useful. And then likewise on the other direction, I think is where you can play with lossy data formats. So for example, displaying a picture and then being able to look at that picture, we can take in a ton of information really quick, even if there's compression artifacts in that picture, and other kinds of incorrectness. Point being, I think that we should absolutely look at the human abilities as an API and try to maximize the bandwidth those APIs offer us.
One thing I was about to point out here is that one of the reasons why we don't use speech is because speech is very ambiguous. It's got a lot of redundancy into it. Again, depending on which language you speak as well. If you speak in English, it's a very slow-spoken language with a lot of different words that you can use. But if you're speaking in French, it's quite fast in comparison because it's got a lot of redundancy built into language. So that's why when you hear it's fast, there's a lot of it's just saying like, oh, I can hear the differences between these different words. So in that regards, speech isn't actually a very good medium to actually transmit information, especially to a computer, because it's very ambiguous. It's very metaphorical, but compared to text, which again, it's digital, it's very much like what I type in is exactly what I want kind of thing. But also, the other thing you have to understand is when I'm speaking, I'm only saying one word at a time, and I'm training it linearly. With my fingers, I don't just type one letter at a time. I can do chords and such like this. So it's not just 1 but 10 times 10. It's more of I've got a combination of all I do. So when I'm doing chord, like again, think of a piano, or in that case, or a guitar, or any instrument, they're using all of your digits, and then you are kind of bringing them together. Like again, the simplest one for most people is copy and paste. That's 2 at least. Maybe sometimes you do more shortcuts, like again, I'm doing Windows, say just for example, like Control Alt Delete. That's 3 you're using both of your hands. So again, the bandwidth there is a bit more precise compared to speech. So that's why I wouldn't want there. But one thing, going back to the speech thing and redundancy, and this is half the problem with the text format rather than the AST, as we were talking about earlier, is when I was designing Odin, there's a lot of stuff I've baked into the compiler to actually check for that redundancy, because you actually need it, surprisingly. You can't be extremely precise in how you type. You have to have a loosey-goosiness to it. C has this. Odin has this. Zig has this. Pretty much every text language has it to a certain extent. There's this loosey-goosiness to it. Again, it's the awful word to do it, but it's the redundancy. And then when you're dealing at this textual level, you're going to have to deal with this, how do I put it, oddities of text where you can't get around and you have to try and figure out the stuff. So a good example of this is, I'm trying to think in text, when I'm parsing it, I don't know if it's actually in a valid format. I don't even know if it's got valid tokens. So when you do the tokens, you try and parse them as if they are valid, and if they're not valid, you try and recover at a certain point. Just keep going so you can give better information to the user. Same with the parsing. I have synchronization points where I can try and recover from where there's a bad parse, but then still parse it as if it's good for the user. If you skip all that stage, you've got rid of the syntax problem entirely, because the AST has to be in a valid syntax state. This is also where the problems with a lot of like the language server protocols come on nowadays. I know, at least for the Odin one, which I haven't worked on at all, I've not even touched that code base, but Daniel, who has worked on it, a lot of his stuff is just trying to figure out the partial parsing and trying to only update the bits which have changed, and trying to figure out when people have done partial parses, how do you parse along that? Again, this is all well, if you actually had the AST stage again with the Dion thing, well, you know that's only partial because it's not complete, so it's its own isolated section. You've already got rid of a whole point of issues with redundancy, trying to design a language so you can do that. It's gone. Completely gone. Categorically. So it's one of those where, again, the speech and the text have a very similar human problem, which we have solved through like speech. Again, evolutionary, we've got the redundancies in there in the speech. But for a computer, it's like, well, we don't actually have to have that kind of. So hopefully we can just yeet it and it will work.
Yeah. It seems to me like there is it's clear that there's going to be some similarities between speech and text, since they're both very much based on linguistic processing of information. And if I were going to explore that space, I wouldn't want the mouse, but I am very curious. I think another part of the human body that is very expressive is still our hands, but the ability to do motion with them, and that can be captured on like a touch screen or a probably that would be my preferred way to do it for programming, is some kind of large touch screen. Not like people try to do programming on the phone, but I think practically I imagine a large like tablet type of programming might be possible, but there would need to be a exploration there that I don't know how to do exactly, of what kind of data structure can you edit with that device that is well suited to that device and that then compiles somehow to programs. But yeah, then now we're kind of off in an area where I don't even really know what to say about that space. And if something pops in your head when I say that, I'd love to hear it. But I don't have any obvious idea of like what the data structure needs to be that you can edit with a touch screen that is also compilable.
Well, one thing you've just told me, and this may sound silly, but it is kind of obvious in that point, is that touchscreen is two-dimensional. When we speak, it's one-dimensional. The audio is literally only you're hearing it as it comes along. And when we program, we care about lines, right? We aren't just literally programming on a ticker tape where it's just one continuous thing, and then we have to search through it. The two dimensions of actually being able to visualize that thing on the screen with our eyes is actually an extremely important thing. It sounds so obvious to everybody. But it's like, no, 2 dimensions is a lot better than 1. In fact, it's infinitely better, obviously. But the other thing is that you wanted to look on a touchscreen, you're saying with your hands. It's like, yeah, because you want to deal with your hands in kind of a 2-dimensional sense. We could add a 3rd dimension, but I don't think that's actually necessarily going to be an easy thing to visualize, even for us. Because when we think of humans, we just try and think of everything in slices of two-dimensional things anyway when we're doing 3 dimensions. And those slices, again, in the textual thing, you can do the analogy of a file, right? There's multiple files, they all layer on top of each other, but they're still 2-dimensional we're looking at. Our computer screens are 2-dimensional. How we write on a piece of paper is 2-dimensional. So humans like 2-dimensional things. But again, this is all just kind of figuring out the psychology of humans and understanding it at that point. What do humans actually want to deal with? For me, when it comes to the programming side of things, I think the actual language stuff, if we're just talking about our goals at this point, I'm not saying we've got it completely, but it's kind of like a well-trodden area of research. The language isn't necessarily the problem of focus anymore. And the reason why I'm saying this in this context is just more hey, we can see patterns emerging from this. I can see a for loop. I can see an if statement. I can see a procedure. I can see a whatever. And that just pops out. And what you wanting, at least when you would get one of the Dion, I remember seeing, I think this was years ago, about the light table thing, if you remember, for like the closure language. One of the beautiful things I was loved from that little demo was like, oh, I can just visualize this this function that I'm using right here on the side, move it around as if it's not even actually in the text. So in that sense, I am using the 2-dimensional space to organize how I am visualizing the code in my own mind, but then place it on the screen. So it helps me actually view it. But when you're in text, we're having to open up multiple different panels with the text files. And it's not really, it might be all over the place as well. So it's kind of more of I'm adding my own structure to actually visualize that code better.
I have a concrete example that might be fun to look at with these ideas in mind. How about it?
Yeah.
Okay. The other day, I was working on porting ChromaPrint to Zig, which is a C++ library that takes as input a song that's perhaps been compressed all to hell and is able to figure out, it comes up with a fingerprint of that song, which you can then query their open source database API to find out what song this is, and then grab a MusicBrainz ID. It's pretty sweet. So I got the port done in a matter of hours, into Zig, and but it took me 3 days to figure out the bug that I had introduced. And because I was getting results, but just with a lower score than expected. So there wasn't a crash or, something like that. It was just slightly wrong. And I had to figure out what was going wrong in this, DSP sort of library.
Mm-hmm.
And spoiler, I had typed 444 hertz for A, the music note, instead of 440. So it was just off by a little, and it was just subtly wrong. And I had to figure this out. And eventually, I mean, I can tell you what I did to debug it, but maybe we can look at this from the perspective of Alan. What would you want the programming environment to look like for this problem?
That's a wonderful question. Why don't you tell me how you debugged it? Because I'm going to think about what you're asking, but I haven't solved that problem before, and I'm not sure that anything is materializing in view for me, just off the top of my head.
Right. So I started by uh, trying to add introspection into the pipeline. So the pipeline is it takes as input a song, it decodes it with FFmpeg, it runs a fast Fourier transformation on it, and then it does a 3 or 4 more kind of passes over the data and coming up with different information each time. And at some point, it's done. So what I did is I just started doing a basically binary search by picking a point in the pipeline and then creating just custom coding a visualization for that data. So I actually just made it print to like standard error, just entire dumps of waveforms, just like floats. And then I had a second program that would scrape the logs and convert that to an HTML page, which I could just then open and look at the waveforms of, like almost just like a visual terminal, in a sense. And that didn't, like, they just looked, and then I compared that with the correct version and the wrong version, and then I tried to see if I could see a difference, and the difference was too subtle. So then I did the same thing, but for the input of the fast Fourier transformation, the output of the fast Fourier transformation. And at some point, I was able to just visually look at it and see, like, okay, I think that those look too different. I should figure out if there's something going wrong there. And then that got me within, the vicinity of the function that had a typo. And then when I saw the typo, I smacked myself in the face.
Gotcha. Okay, so that clarifies for me pretty well what the debugging challenge was, and also the structure of what you were doing. In a case like that, where you have a pipeline of data transformations, I think one thing that I often feel could be improved by exploring the data structure of the one thing that could be improved by putting all these pieces together and forming a new interface, let's say it that way. So if the pipelines that you described are all encoded in the text, so there's no how do I put this? There's when I have written similar software that has a very clear pipeline, like you have a bug somewhere between input and output, and there are stages of the conversion. When you go to write down, say, each of those procedures that makes one of those stages, the text feels like fine. Like it's pretty much good. Like I like to write my algorithms that way. I don't like to specify algorithms visually. I write them as pseudocode. That is the convenient thing. And real code is just the slightly more specific version of pseudocode. So that's fine. But as you then start to go to higher levels where you go, well, I recognize that what I'm orchestrating here is a pipeline, and the pipeline is shaped like this, you are kind of now using the text a little beyond its strong suit, it feels like, and you have to start manually going like, okay, I know in my head that the pipeline is right here. And if this was all completely visualized, there's this visual programming system called Houdini, which works this way, where it's for making visual effects. So it's kind of playing this problem on easy mode, which is that, like, since it's making visual effects, it already has visual output all the time to show you. But you orchestrate things as stages of, like, I compute something here, and I compute something here, and I compute something here. And so all of what you described is automatically visualized because you've constructed your pipeline in a visual way in the interface. And so the interface has a natural place where it can put the sort of intermediates in the computation. And so interesting things can happen, like if you have an error at one point in your pipeline, and the pipelines can also be nonlinear. They can sort of branch and merge the data flow. It's a full on, like, directed non-acyclic directed graph kind of data structure, I believe. And so in that space, if there's an error somewhere where, the inputs are invalid, it can then sort of mark the poisoning of the whole tree, and you can just look up the tree of error. Where's the root of the error? It's like, that's the interesting point. It's just visualized the first time you run it. And so the point is not that that it would be significantly different from what you did, but that it would be kind of a built-in assumption of the interface that this is something you're going to do a lot. So let's surface this kind of thing all the time while we're working with it.
That's a great example.
Yeah, and that's exactly what we do again at work in Django Effects. Obviously, Emogen, LiquidGen, GeoGen, all of them have a node-based system. And especially let's take GeoGen as a really good example of this, is when you click on a node in GeoGen, you can see how that, again, the landscape is being generated at that stage, because again, each node effectively equates to a compute shader, right? So you have this node, it's part of a DAG, so a directed acyclic graph, and these passes go through and how you manipulate it and how you process it and deal that way. But you can click on it at any stage, literally any node, and see what it's done. So you then, as the artist, gets a direct feedback going on there. And then you've got a UI, obviously, to do all the inputs and sliders and whatever when you're on that specific node. But they have this different visualization of the thing. You also have timelines in our software as well. Like timelines are a different type of visualization. Everything's just node-based. You want sometimes timeline-based things. So we've taken into account all of this, and all our code is literally structured around this, uses pretty much the exact same code for all of it. And it's a very, very useful thing to see how it gets processed. Like literally click on this, see how it processed at that time. Even if you click on the end result, it will show the end result. So, and you can just mix and match, pull them together. And it's kind of just, it's lovely to do. And again, Houdini is an example of this. But one thing we try to do is make sure our node graph is not Turing complete. So there is no conditionals in that regard. There's no loops, nothing like that. So whilst something like Houdini or let's say Unreal Blueprints or anything like that, those are very complicated node systems, and they do a hell of a lot more than you realize. And yes, they may be very powerful, but they're not necessarily, I would say that's not the language you want to deal with. That is more of the visualization of the process, and then the language itself should be not of that form.
Right. So this is where I think it gets really interesting to me to pick your brains about the language part. So I think we're starting to connect back to my original question in little subtle steps here. The thing you just said I find interesting because it's clear, I think from what I'm hearing from Bill a lot, is that you're a strong advocate of visualizing everything, but not necessarily constructing most of it with a visual editor or with a visual.
Not necessarily. It's just more of, I have actually friends who are actually working on these again, but they're basing their languages off like either Lisps or Forths, actually, not Algols. I know one person was doing it for Odin just for fun, but the interesting thing is just more of a, again, if you're going to do that visual editor thing, which I know you're very interested in, for me, it's just more of a, yes, but that is a long-term project where you've got to design the language for that specifically. I do not believe you'll be able to take any pre-existing language right now and just embed that into there and make it work. You kind of have to design the language from scratch for that new environment, which would still be a very textual thing, but because there's a lot of things in the design. Again, you don't have the redundancy, you don't have to worry about all the stupid text generation. You don't have to worry about tokens being different things. Oh, a good example like this is Zig. Zig has a rule where a token cannot go across multiple lines. Everything can be passed in a single line, right? While in Odin, we have multi-line tokens for like strings and comments. The reasons why we do both of these, we have different approaches. It's complete different reasons, obviously. I know one of them, not the only one, obviously, for Zigs, is that most text editors are crap. And how they do, and not just that, how they edit and also how they do syntax highlighting is on a per line basis, right? So, and the way they do it is with regex as well. So if you actually define your tokens to not span across multiple lines, it makes your syntax highlighting trivial to do within these text editors, right? I prefer like, okay, yeah, but I actually do like the multi-line things, especially for comments and strings. Like, I think they're very useful. And actually, most text editors can handle that. It's not that much more difficult to handle just that extra case. But when it comes to, if you get rid of the textual degeneracy aspect of this, then what the problem becomes, well, I mean, it's degeneracy in technical sense, by the way. Literally, yeah, as in it has multiple states that you can't differentiate from, right? Sorry, I'm a physicist by profession, so I keep forgetting. People mean that in a different sense. So the thing in that particular case is that if you just skip the tokenization and completely the parsing stages, you already have all of that information at the text editor level. It doesn't have to do anything crazy anymore. It doesn't have to do any bodges or hacks to support multiple languages. And there's the thing is, this is also an editor just for one language. There's the caveat as well.
Yes.
You could have another mode in it, which goes back to the text mode again, which is only text editing files. But there's your caveat, is that this would be completely tailored to one language and one language only. Because it has to be. Like, that's what you've designed, the entire environment. The entire tool chain would be that. So it's the AST editor rather than the text editor kind of thing. I'm saying AST in a general sense.
Yeah. So that is a really important topic. And again, this is we're sort of taking little baby steps back to the broad question I asked initially, which is like, what is language design? And here's where I have a big problem with the standard visual programming approach, which is that I don't think that is a viable solution. I think that the fact that we have a tool chain right now where we have a text editor and I can use Forcoder and you can use Sublime or VI or whatever you want, and then we can both program together is significant. And if we get to a point where, okay, if I choose a language that chooses the editor and I can't swap out the language and keep using this editor, and I can't swap out the editor and keep using the language, that feels like a problem. And of course, the knock-on effects down there, it's like the more of these things that sort of become mono tool chains that they do not have interchangeable parts feels like a big problem to me. And so I'm much more interested in thinking about it just in terms of, well, text files and the file system are a data structure, and compilers are a thing that ingests that data structure and outputs another data structure, which is, the binary files or the object files more technically. And what else could be done if we are allowed to change that ingest data structure, right? If it's not text files anymore. But I'm not saying that but I want a world where that data structure is still language agnostic in some sense, in the way that it's just a data structure still.
And unfortunately, I'm going to state that bluntly, so that's impossible.
Okay, I'd be very curious.
Wait. I disagree because you guys are making me think of some new ideas that I haven't thought of before that I think are really exciting. Okay, what if we're still using textual programming, but in the same way that like when you compile ahead of time compiled programming languages, it puts debug information in as extra data that it annotates the machine code and then gives the ability for tooling to do a bunch of extra cool stuff, debuggers. What if we did that kind of thing, but for visualizations? So just as brainstorming, like you have a function. This function is rather complicated. It has some inputs, it has some outputs, and you want to visualize it. What if we had a meta, a way to describe like meta information about this function, describe the form of its inputs, the form of its outputs, and then those annotations go into the binary, and then debuggers which understand this extra standard of visualization are now able to know when that function runs and put it in a graph, maybe make a picture. Depending on the annotations, it can have a bunch of different kinds of visualizations available, and you can interact with those visualizations programmatically because you've annotated it with code. Does that make sense what I'm saying?
Yes, but that's not what I was disagreeing with, but it's a good idea because the idea is you're actually embedding more information about the semantics of the language. And when I say word semantics, I mean denotational in this case rather than operational, right? Because the operational one is the machine code. That's obvious. That's already encoded. But the denotational stuff is completely lost. So if you added like some information back into that in the debug information rather than just types and symbol names and such, symbol locations, then yeah, you've got a hell of a lot more in there. But again, that's still for very much not say one language, but it's going to be a certain family of languages. Like if you design it in a way that's for our goals, that's great. But that won't work for the Lisps or the Forths or the Haskells, the MLs or whatever. You're very much stuck to a certain paradigm.
You could define this standard as having certain kinds of data formats. Maybe, for example, with my problem earlier, one of the formats it supports is just a waveform visualization, or rather just a graph of floats, over a time series. F32 IEEE 754. That's a very standard data format that Lisps understand. I don't know about Algol. Probably it works fine. Like you just need an array.
Algols are the C's, by the way. Algol is the C family, right? Everything's spawned from that C. Pascal, Zig, Odin, they're all Algols, right?
Got it. Okay.
That's what I mean. That's what I was using that term for.
Yes, if I may, I think we have a really interesting fork here, and I'd like to go down both paths. So I just want to earmark both of them, and then we can continue this conversation. The one was I want to hear more about what Bill has to say about why it's impossible. But it sounds like we already kind of made some steps in the other direction, which is this idea of, again, we're talking about how to put more visualizations um, into the system. And in this case, it's visualizing sort of the runtime properties of the program in richer ways, if I'm understanding a very high level understanding of what the goal is. And since I've worked on a debugger over in the last few years, I'll give you a little bit of an idea of how close we are to something like that and where I think the lines are drawn in the current ecosystem. And maybe you can go from there to see how practical it is to finish that idea off. But from what I understand, like right now, the only reason this is difficult, and this also ties into your example, Andrew, that you started us with the FFmpeg debugging problem, which is that you had to go in and hand write the visualizers for the stages. It was like they didn't already exist. You didn't have a visualizer for the things you were interested in visualizing that were just plugged in right away. And this is why I said Houdini's kind of and I think Embergen's in a similar situation, since the whole point of those computational systems is to create visual effects, they are in the nice place where creating a visualizer for them is sort of the same thing as creating them, in a sense. Like you see what it's doing by seeing what it did, whereas with something like FFmpeg, to see what it's doing, you have to add another thing because what it did wasn't a visual artifact. So to me, a debugger... and the way we do debugging info seems like it's already very close. The only difference between what we have and what you're describing is a giant library of visualizers that can be hooked up to various types in your language. Is that about right, or is there something I'm missing from what you're pitching?
That sounds exactly right.
There is the other caveat, which how do I put this? Programmers are mostly to blame as well for these problems. And what I mean by this is that programmers will put up with a lot of crap. And not just that, they will think this is good with Stockholm Syndrome. So an artist can put up with a bit, but they'll know when it's like, no, I can't see this, right? I need to do something. And again, we have a company which we develop software for artists, right? So we actually are trying to make a product for them and actually we give them what they need because they are non-technical people in that sense. Some of them may be tech artists, but like many of them are non-technical. So they need something, the non-technical visualization. Programmers, on the other hand, most of them are sadomasochists, and I don't mean that as a joke. Right, a good example of this is, again, go back to debuggers. How many Linux programmers actually use a visual debugger? How many? Rather than using GDB or LLDB in the command line.
Yeah, they just don't work very well.
Few.
Yeah.
But why? Why isn't there one? On Windows, what I love, I don't just use, we have loads of them. We can use Visual Studio. I can use Remedy BG. There's the new RAD debugger. These are all visual debuggers. They are orders of magnitude more productive to work in than using GDB or LLDB or whatever your favorite textual command line debugger is, right? Because they're graphical. But the thing is, Linux, this is, I don't want to make it a rant about Linux programmers too much, but it is very much like you could actually make better tools for yourself, but you don't. And why? Because there's two things. It never pops into their mind that they could, but two, it's also they think, oh, this is the right way to program already. I'm like, what? It is literally a bit of Stockholm Syndrome, as well as the sadomasochism, because it's very much like, well, I've had to suffer through this, so you've got to suffer through it now, and I'm enjoying the suffering as well. It's kind of the, and it is in many ways. And again, it sounds horrible, but like you can make it already better. It's just no one's going out there. Again, RAD debugger will eventually be on Linux. I know it will be, but it's one of those that, again, why is it in the current year, which is 2024 of this recording, that we've had to wait all this time when these? It perplexes me. Like there's just a lot of, yeah.
I think points 1 and 2 that you made are accurate. However, I think there's also a point 3, which is that we've found this local maximum of GDB. Like it's a red herring, it's a distraction, it's a solution to the problem that's suboptimal, that's good enough. And
I wouldn't even call it a local maximum. I'm not even that polite. Honestly, there's a reason why people do printf debugging a lot, because GDB isn't good enough. Like a good example of this is, again, writing a compiler. A lot of the time, you want tracing as you're debugging, right? You don't know how do I put this? You have dependent state. Like you want to know when this hits, depending on something other in the chain. So doing a trace of your program is actually the better way of doing things. So a printf is a dumb way of simulating that. Modern debuggers like Visual Studio, I say modern, Visual Studio has been around for over 20 years, can do that to a certain extent, in a better way, not brilliant, but then GDB is like, yes, you could hypothetically do it. You just have to make the programming in its own little bytecode to do it. I'm like, wait, what? And it's just, there's a lot of things where, I don't even think it's a local maximum, because it's like, I know what Visual Studio is like. There's a reason why loads of developers, especially for games, prefer Visual Studio for development, and they haven't gone to Linux yet. Because it's very much like, well, the tooling's awful.
I'll add in a little bit of coloring on this with maybe what are we on, the fifth point, something like that, about why it's not there, which I think does maybe make it slightly. This will support Andrew's point that it's a local minimum or maximum, which is that there are decisions in the Linux kernel and in the tool chain. I'm referring to Dwarf, that are rather large barriers to making a good debugger. So the fact that GDB works is a local maximum in the sense that, like getting to the point where you're going to have a visual debugger on Linux, it's not to say it was ever impossible, but it's always been tremendously difficult compared to what it means to do the same thing on Windows, because of decisions that were made in the entire ecosystem that just didn't assume that was a priority.
Yes.
So...
yeah, I think all three of us here can agree that Dwarf is awful, because we've all probably had to deal with it for a very, very long time.
I'm not sure I'd agree with that, actually. I found the spec like pretty easy to implement. I mean, I don't like it when debugging doesn't work. That's my main complaint.
Yeah. Oh, okay.
But I don't know where the difference. I mean, it doesn't seem, when I read the Dwarf spec, what I'm thinking in my head is like, oh wow, GDB implements this terribly. You know.
Yes. Oh, okay. That's a good way of putting it. Yeah, that's true as well. Yeah.
Yeah, I would say that the big difference between Dwarf and the CodeView PDB stuff is that CodeView and PDB was specifically designed to make Visual Studio, and so it was designed to make a visual program or debugger easy to build. GDB was designed with other goals in mind, and so yes, it is probably not that different to export either one. In fact, GDB might be better if you really care about debugging optimized code and other fancy things like this, but Dwarf is not made to be just a simple, here's how you make a visual debugger. Like, it didn't prioritize that in the way that the PDB format does. So, yeah. But yeah, let's switch over to the other fork there. I'm really curious, Bill, why... So I was trying to say that I'm interested in a data structure that is not strictly just text files in a file system, but that you could still build compilers on that data structure, so that you're not locked into one language, one editor, one mono ecosystem. Why is that not going to happen?
Well, so there's a few things here. You want, again, a C like an algol. You could do that hypothetically for a Lisp or a Forth, right? That is actually possible. However, that is just because their AST at the end of the day is so simple and basic. At the end of the day, a Lisp is what? Oh, you've got an array of, literally it's just a linked list where you have more linked list things and they all get terminated with a null at the end, and that's it. It's such a trivial data structure. And each one of them, each node on this is effectively like an identifier, a symbol, or a token. That's it. There's nothing else to it. But when you come to an algol, again, you take C, Odin, Zig, Pascal, Rust, whatever, there's a lot more to the structure of the code which encodes certain aspects of the language. In fact, the syntax is influenced by the semantics. So you can't have a generic syntax because that is actually defined by the semantics, weirdly enough. So a good example of what I mean by this is, think about an if statement, right? Do you think, oh, that's the trivialist one? We've got, it's got a condition to it. It's got the then body, and then you've got the else maybe. There's an else body as one, optional one does that. Well, that idea of an if statement is the most simplest thing there. You've got three elements. But then you've got to think about, okay, so what does this actually tell me about, say, what can I do with it and such? Does this, and you think, oh, okay, we can start editing this and this. But you're still instating aspects about the language and how it works in the syntax itself. So it restricts where you can further and further go. So when I'm saying you want it to be completely generic, I'm saying, great, then you've got it doesn't make any sense. Like, I mean, it literally just doesn't make any sense unless you're going the full Lisp approach. But in that case, then you've just defined it to be a Lisp, right? And then the other issue you've got is just the Lisp thing is like, yes, well, we're so powerful because we're just linked lists. So that's your data structure, right? It's not just a tree per se. It's just effectively a binary tree, in fact. That's what it is. That is the linked list of, say, I should say linked list. It is literally a binary tree. Nothing else. So an algol isn't a binary tree. It's a very complex thing. Yes, you could hypothetically represent everything as a binary tree, but it wouldn't ever be useful. You wouldn't want to actually modify that code, represent that code, or do anything useful.
Right.
And not just that, it's beyond what you, again, it's far beyond what you've ever wanted anymore, because again, you're just trying to pretend to be Lisp.
Yes. So
I think I'm a bit lost. Can you back up a bit and explain the context for this?
Yeah, I'll fill that in because I think I understand a little bit, and I realize that there might be some implicit assumption between Bill and I here, which I'm actually gonna shift away from because I think maybe Bill is assuming that I mean something a little more narrow than what I do.
I might be, yes.
So we'll clean that up. So first of all, back when I did the Dion experiments with Ryan in 2020, we presented them. It was kind of just my first step. Both of us, we were just taking our little first steps into figuring out this space. And at the time, it seemed to me like what Bill was saying was probably true. And I was worried about it, but didn't know what to do about it, which was like, we were thinking that the thing to do was to implement a new interface for programming where instead of the front end of the interface being text files and a text editor, it's an AST file and an AST editor. And the reason that this was attractive is because it meant you could start exploring questions about what it meant to do the fundamental editing. Sort of earlier when I was saying, you can build a text editor and the baseline thing is that one keystroke is 1 byte of new data, and then you can add magic spells. Well, the idea was, if you shift to the AST level, you can get to a baseline with a little more leverage than that. You can get to a baseline where it's more fundamental to rename everything as a single idea because you don't have to have linking happen by identifiers anymore. Instead, identifiers are like visual labels that you put on things, and they're linked by their semantic connections behind the scenes, and you manage that in a different way. And as we were working on it, it just seemed to me like the only chance we had at making it work was going to be to just define it as a language and an editor together, because we needed to get both done in the course of about a year to make the demo, and I couldn't think of any way to generically define the data structure and then define a language for it simultaneously in such a way that the genericness of the data structure was obvious. In order to prove that it's generic, you would want to build 2 languages, and it's just that wasn't going to happen. And I still think even now what Bill is saying is probably true. At least if you start from the perspective that I had way back then, which was you look at a language like C or any kind of C, maybe a cleaned up, fix all the grammatical issues that make it impossible to parse unless you start from the beginning of a preprocessed file, right? You fix those problems, and then you just say, okay, we got a basic C, and then we're going to identify the key structures here, like structs and enums and procedures and blocks and ifs and loops, and build interfaces for constructing each of those things, and then maybe try to simplify it. So it's all the different types of blocks could really be the same thing, but then you have to pick between which kind. Are we doing an if here? And then the interface for building your ifs follows from semantically what if means. And if I understand what Bill is saying, it's that you have to know semantically what if means in order to build the interface for editing it in this approach. And you correct me if I'm wrong.
No, you're not wrong. It was just more of it's very hard to express sometimes in speech. Again, I don't find it's very hard sometimes to express this, but it's very much how do I phrase this? When you've got a language, there's a lot of differences in it. Like each control flow in Odin or even Zig or even C, let's just do C. Yeah, each control flow is quite distinct. An if and a for and a switch and a while and a do while. These all do have different forms to them and have different semantic meanings. A switch statement in C isn't actually just a chain of if statements. It isn't. It's actually like a weird amalgamation of some sugar over case statements with a jump table. And that is the syntax could have been anything. That's correct. But it's like that doesn't. It's a different idea. And once you add a new control flow, it's got a new idea to it, which has a different layout and a different structure. Again, a case statement is a very good example of this, where it's kind of like the structure's a bit all over the place. Like it's not simply writable. If you ever written a C compiler, it's not actually like a simple AST for that in that sense, compared to say something as trivial as say an if statement is. Again, I'm using just a very poor analogy here, but there's a lot of things where you bake into it just the different semantics is what I'm trying to say. And you want to express it different. Like, again, the difference between a C-style for loop and a for each loop, maybe in that language, they may look very superficially similar, but the data you store on that tree is very different.
Gotcha. Yeah, I think I follow now, and I'll keep responding, but I want to just double check in.
Yeah.
Andrew, does that make more sense, or do you still have some questions?
I think so the context is trying to manipulate a higher level construct than bytes of text. Is that right?
Yeah.
Yeah. Okay. Yeah, I'm following along.
Okay.
I guess my kind of burning question as I listen to these ideas is like, what would you actually do with that you can't do with a textual representation? But you can drive the conversation on just that's kind of what's in my head.
The brilliant example I brought up earlier was this was a demo from well over a decade ago. It was Light Table. So Light Table didn't turn out what I remember seeing it out as be, but this was a kind of a visual editor for Clojure. So Clojure's in the Lisp family based on the JVM, and it's actually quite a nice Lisp. I hate Lisp so much, but this is probably one of my favorite Lisps. And it was a very nice thing, and one thing they demoed was the ability to literally drag around, like, oh, this function effectively uses another function, so I can click on it, and that pops on the panel on the right, and you can drag that round, view it around, so it's not actually text-based anymore. Like, I can actually visualize the things that are associated to it. So literally, it's really nice. Like, I can go on I don't have to use my keyboard, I can use my mouse, doesn't matter, but I could literally like, okay, this function here, can we pop it off in the window size? Okay, that's great. Because you don't need to, and you can say, what does that depend on? You can sit and see the dependencies and go through it, because it was effectively dealing at the AST level. But because it was a Lisp, the AST and the syntax are pretty much like one-to-one in that regard, aren't they? There's a kind of a lovely beauty of that Lisp, which is why people love the Lisp. I can never remember the technical mathematical term for this, but like as you're viewing it, that is the AST. Like you can trivially translate it. So that's why it would work in the Lisp family. But when it comes to like the algols are, again, the Pascals, the Cs, just are a little bit weirder. And they don't have that simple data structure going on there to view. But again, the same idea could apply. Like I could literally go into an Odin program, click on something, and it visualizes the function I'm using. I'm like, oh, can I see the data structures and how they're related next to that? Okay, good. What's the dependencies of this? And like, just click, click, click with my mouse or a keyboard. Yeah. It doesn't matter.
That's kind of my point, right? Like you're describing, great example. I love that kind of visualization stuff. But it doesn't really have anything to do with AST representation, right? I mean, you just pointed out you can do it with Odin. So
no, you can't do it with Odin. I was saying, imagine if it was Odin, hypothetically. I didn't mean you can do it with Odin. See. So I just meant that as I like literally imagine a language X. Let's call it language X, this magical new one, right? Language X, you could hypothetically have it in this case, and you just literally you can go, okay, what's the relationship with this? And then it would show you a snippet of it effectively in text. And then you can manipulate it, drag it around. It's not just text, and it's not just taking a clip from the file either, because you could just say, okay, ignore all the comments on this, or sharp moving the comments around. It's a very basic thing. It's a bit of like a tweening option going on here. Like I know it's a bit boring, but you can start visualizing it better. You can then start seeing the dependencies, and those dependencies could be drawn out, showing you actually this is where this is relating to what. It could even show you the DAG operations going on, like here's your code, and now we can visualize this code now as the DAG itself, like the SSA format or a graph format. So now you can actually just literally do so much more. And again, that it's not just the AST. I'm just saying that the AST is the bit that's so much easier to manipulate with these tools, rather than having to go through the tokenization and parsing stage every single time, especially when you know the AST is going to be valid. It's valid syntax.
You're focusing on the AST, but that's not really the point, is it? Like the actual...
No. I'm talking about a typed AST as well. I'm not just talking about an untyped as well.
It seems like the actual difference is that it's a functional programming paradigm.
When you say functional, what do you mean?
Like a pure function. We have
no, I'm not thinking of that at all.
But that's why the light table example works, not because they're storing AST. It works because it's functional.
No.
Yeah, I'd like to clean this up because it is kind of interesting. I think what will help here is I have to admit that I've become more skeptical of the AST data structure since my time working on the Dion one, for two reasons. One, that it, like I said, it does have the problem that I think Bill was talking about, which is if you approach it from that angle, you have to build one editor for one language. They kind of become a coupled thing. So your language designer also becomes a GUI designer at the same time, in a certain sense. And maybe that's good. I do think it's important to think about how the whole interface for creating software comes together. But I think that the ability to interchange and to put different types of pieces together is pretty valuable, and that one model trying to capture the whole universe feels like a dead end.
It's not necessarily a dead end. And also, to be very clear for you and also the people listening, I'm using the word AST just because it's familiar to people, right?
Yep.
I'm just saying that this is another level extraction. You've not just got the text and then the tokens. You've then got the syntax tree itself, right? You've gone 2 levels further along, and it's like, you can actually work at that level, right? And there's something where just even that level alone is more productive than not having it. In fact, sometimes it's even more productive just to have the tokens. There's a lot of the time, and this is nothing to do with this is not. A lot of time programmers forget they can just do tokenization, right? And you go, like, if you tokenize a file, like text has got text file, I'm like, look, you can actually manipulate the tokens around. It's like, oh yeah, I can do that, can't I? It's nothing to do with like they don't know how to do it. Some people don't, and the ones that don't usually rely on regex a lot, right? They'll use regex for everything because it's the only tool they know. I'm like, you could just use even a pre-built tokenizer that does the job, and they go, oh yeah, this is a lot more clearer, and now I can manipulate it or process it at that stage. But that's all I mean. It's like, it's just more of a getting off just the thinking about text and like all the oddities of text, and like just go a few further steps on. You can even go further on. Like, I know, again, the Zig compiler is a good example of this. You have multiple levels of IR, don't you? So at every different stage, you're using that mainly for, again, caching, but also you could do that for analysis. So when you're parsing, you turn it into the ZIR, don't you? Or at least you used to.
That's right.
And then I say the names. I'm just trying to remember the names off top. And you get the ZIR, and that's the thing you're caching, and then the compiler then starts working on that. And it's like, it's not just that, yes, you've got now skipped out the parsing stage. So to me, parsing is very rarely the bottleneck itself, right, in any program. But that's not the point. The point is, the thing you're dealing with is that intermediary format. And that's the more useful thing to deal with. So that's why, again, that's all I mean by the AST, is like, what Alan is trying to figure out, from what I understand, is he's trying to find out, okay, is there an intermediary format that is better to deal with
for humans?
That's still for all of this.
Right. So to connect that up with Andrew's question, I'm still I'm happy to spend as much time as we need to make sure this makes sense. But to me, the argument for why it was ever interesting to look at an AST instead of text is just that when you're implementing the editor and you look at how complex it is to do something, which is conceptually trivial, like put this side by side with the things which it depends upon. So this function is defined in terms of calling 3 other functions, and I want those and the structs that make up the inputs and outputs of all of these just splatted right here on my view. You can do that in text if you've got good language, good code intelligence going, and you can jump to all of the definitions. The point is that goes from being an entire engineering problem to literally like a trivial command that you write in 10 lines of code. And so how many more of these trivial commands can you write when you never have to stop and think, wait, did I analyze the code for this particular purpose? Like, have I laid out the process of parsing and then feeding that parse back in the right way to use it in all these different ways? And so in the Dion demo, for instance, we were able to just say, like, okay, now that we have made this data structure primary, we can play with that and make a new data structure, which is just sort of a list of references, and we can start building these like palettes of useful things. We called them slices. It's like these things all kind of go together. So sometimes you just open up this particular slice or palette of code things, and these are like some procedures and types that you want to edit together. But they can also participate in other slices, so that it's not like they're in folders so much as they're just grouped in this one particular view. And that's easier to put together and make an editor that makes that make sense when you're no longer saying, well, what we're really doing is putting like 3 different text files side by side and then smooshing out some of the text, or like it gives you new options for what the interface can do and for how easy it is to do that high level stuff. I hope that makes sense.
I see. Yeah, thanks for explaining that. That really helps me understand. And in my head, I was thinking like, well, you could still get that by just creating an AST.
Yep.
But your point is that that is a bigger engineering effort. Now it makes sense.
Yeah, it turns out that it's an extraordinary design effort to make a editor that is joyful to use that works on this principle. Especially if you're like, let's just clone C and make the C AST our data structure. I don't know how to make a joyful editing experience based on making that data structure the interface. So that is sort of the other end of the problem, and I think that's where I have a slightly different idea of what I'm looking for than what Bill is talking about, which is I'm not looking to just take the existing tool chain and slide up. That was the idea in the Dion demo, which is just, hey, let's cut out text, let's cut out tokens, let's get to somewhere deeper where the semantics are cleaner, and let's start going there, because everything from there down will be simple. The problem is when you go to put the new editor on that, it turns out that is less trivial than you think, and if that's going to be non-trivial, then you're talking about a huge effort to build a good editor that is then tied to a single language.
It's not just a huge effort. That is decades.
Yeah,
literally, that's a decade at least of just research and development.
Yeah,
because you're not. It's designing everything. And for me, I'm like, look, it will a decade. I've been working on Odin now for nearly 8 years, so I'm nearly up to a decade already. And I know Andrew was as well with Zig, similar time. I think he started in 2015, and I'm 2016. Ooh. So
almost a decade. I still have half a year left.
Exactly. Oh, now into middle school soon enough. It's just kind of more of that effort. But the thing is, like, this will take a lot of effort, and I know it will. It's just the question of, like, what you were thinking about, like you want to be able to reuse things and don't just have to be gone down one route. And I agree, that is something which is a nice goal to have. I just think, we're still not even at the stage where we have the one language example, right? Which is more of a, yes, we're trying to think, generalize it. I'm like, look, this is going to be, I'm not even joking, multi-decade research to get there. And that might sound like daunting to a lot of people, or even not even just that, but like people go like, nah, we can find a shortcut, guys. I'm like, there might be. I'm not a smart enough man to find it yet, unfortunately. But it's one of those where I'm like, look, this is a good endeavor to go. Like, even just the simple things like I was explaining earlier, like just, you could have a better visual debugger just on Linux. Like, that doesn't exist. Like, a brilliant visual debugger that I think is absolutely amazing, and you'll be surprised me saying this, but Xcode for metal shaders. It is one of the best shader debuggers I have ever seen, because I can just click on a pixel and see the entire history of how that pixel got created.
Oh, that's nice.
Yeah. So this is one of those where I'm like, oh, I'm using RenderDoc, and I'm like, this blows RenderDoc out the water. And I think it's also because the developers who were working on Metal wanted such a thing as well, right? It's one of those things that went, oh, we know what we're doing. Actually, we want these tools to do it because they don't exist yet, so we'll make them, kind of thing. And I'm like, not enough developers are doing this. Like, I'm not saying this is a call for action, but I'm like, you can make your own tools better for yourself, and it wouldn't take you that long to make them even slightly more productive yourself. It's when I made my own language, for goodness sake. I'm actually a hell of a lot more productive in Odin than I was in C, and I was very productive in C. And this is one of those things where you don't realize, you just have to take a step back and go like, oh, how do I improve my own productivity? Because that's what we're asking for, is how do we make me be more productive, and not to be bogged down in the minutiae of, oh yeah, I've got to deal with that thing, and I've got, oh yeah, I can't do that because of X, Y, and Z, and it's just more of a, can I just not say abstract things more away? I hate that kind of like conception of abstraction in that general sense. It's a bit too abstract, obviously. But what I mean is more of a, people could just make the world better for themselves now. Yes, it may make them a couple of years, but it's going to save you decades if you don't do it. And I'm just saying, I'm just taking. I know I keep going. That's kind of my. How do I put it? Mission statement for visual programming in general. Like, there's the two directions. I know there's one that Alan really interested in. There's my kind of side. Is more of a, which is not unrelated, by the way. They're actually extremely related. It's just that we could still improve the tools we have, sometimes just by yoinking those tools out completely. Like, okay, make something better than GDB, please. That's a good example of that.
Yeah.
But again, that's already clear down the road. But I'm just using that example for audience because then it's familiarity, obviously.
Yeah. So you made a good point, which is we don't even have a very good visual programming system that is visual programming where the language and editor are coupled that people love. But we do have a few examples that exist and that work in the real world, like Blueprints exists and does work for people. It does get a lot of flack for like, oh man, some like the version control story here is still busted and it kind of gets out of hand. Like the experience of maintaining things when they get too complicated to be in Blueprints, but we don't want to hand it off to a C++ programmer yet. Like that's painful. So there's nastiness in it, but it's like it's not that these are impossible to do real work with. Like AAA games probably have used a visual programming system that did actually do work. I think that the reason I'm concerned about that is like you can see that once you have this whole couple in like the editor and language are kind of the same thing. They're not even coupled, but it's that the editor is defined in terms of the language assumes that the language is brought to life by this one specific editor. Its assumptions about what it can and can't support or needs to support and doesn't need to support are based on what the editor is doing and vice versa. And so those kinds of systems seem to me to run into a problem of getting too bloated. And so I look at like, well, why does this work for text files? Why do we actually manage to make systems that we don't feel run into these problems? Like they have their own problems that I'm interested in solving, but they don't run into these showstoppers, essentially, where they can't scale past a certain point. And what is working there, from what I can tell, is that the data structure that you're editing with your editor is simple and decoupled from the language. That the language is another layer of definition added on top of a very trivial data structure. Because if I try to make a very complex data structure like a blueprint or an AST and start editing it, that turns out to be pretty hard to get right once. And to even make it work, you start having to do those steps of coupling it in. So I'm more so these days interested in what is a data structure that is generic. And so to get back to the thing you were saying, Bill, about why this might not work. If I specifically did the AST version, I think that there is an issue there where if I were to say, like, here's what an AST is. It's like a node. It has a certain number of children. It has maybe a label on it. Like I define what a node of an AST is as a singular reusable thing. And then I said, okay, I made a great editor for it or a decent editor for it. Now define a language. You might look at it and go like, hey, you can't even do cases. Like cases are this weird thing where they're kind of a block. They're kind of different from an if. They're funky.
At least in C,
Yeah, right. And so you would, on the one hand, be able to say, well, some of the design things I would do with a text language, I can't do here anymore because you've taken them away. I would say on the flip side that at the very least you can find some language, like if you work within those limitations, surely there is some languages that could be defined, but probably the AST data structure is less interesting as the new data structure. And so that's just to sort of clarify my position since we're kind of talking about it.
Yes. One thing I just want to bring up, which it just popped to my mind, is people, this may sound silly, but text is, we're talking about text as if it's some general thing, right?
Mm-hmm.
Text has a data structure to it already, right? The simplest one we all know is ASCII. ASCII is a data structure. Like, I know that sounds like, I'm being like, what are you talking about? I'm like, when we put text into a text file, it knows how to look at it, right? Because it knows what a new line is. It knows what spaces are. It knows what tabs are, right? It knows how to render all of them correctly. That is a data structure in itself. I know that sounds like it's a very serial, boring one, but it is one.
Mm-hmm.
And that's why a lot of these editors, it's so simple to do because it's just very basic things. Like, here's a character, or it's a code point, or a byte, just whatever it is, like that's you're dealing with, and you can just go through it serially and modify that as you need. It doesn't have any semantic meaning to it intrinsically, but it does have this data structure to it that we can manipulate. Again, it's a character followed by a character followed by a character followed by a character, and certain characters have special meaning. Again, they could be new lines, they could be tabs, they could be spaces, they could be printable things, non-printable things, there could be a bell, whatever, if we think about ASCII, obviously. That is a data structure in itself. That's why it's so easy to actually make all these languages, because the actual text editor thing at the end of the day is so simple to make. Like, anybody could probably make a very, very trivial, anyone who can do graphical things can make a text editor in a weekend, really. Just a very dumb one, though. I'm not saying a good one, But that's because it's not. That's not the heart. That's the thing, is the text itself has a weird like data structure. If that makes any sense. I know it sounds like a very obvious thing, but it's something to be pointing out. And then when we want to add a little bit more structure to it, that's where this again. Oh, it's a token now pops in. This is a multi thing. You got again just one step above, and then you add and then it's the steps. I know I'm focusing on that, but I'm like even the AST thing is not even that thing. Even just going, hey, this is why text is still around and why things don't have issue, because we're all basing around this really, really basic data structure. We all now, effectively, every modern languages nowadays have all kind of settled on UTF-8 as well. Like I can't think of a non-modern language that hasn't.
Yeah. I mean, I agree with all that. The realization that text is a data structure is kind of why I think it's worth exploring why this particular data structure works. I'm going to transition to another topic we haven't actually touched on much yet, but except a little bit, which is Andrew's been he asked me early on if I was talking about, compiling down to executables, and then sort of what the, I talked a bit about my idea of this being like trying to build the interface for constructing software. And a piece of that is the front end editor stuff. Another piece of that is what is the back end you're targeting. And I want to spend a little time talking about that too. And in particular, I know since you've both built languages that are, C-likes or algols, Bill has been teaching us to call them algols. The interesting thing, though, is that they all have a very specific C-like thing, which is that they participate in the whole C toolchain, which means like they still go out to the same operating systems that C was sort of the founder. C founded Linux and to a certain extent Windows, and so the executables there and the object files there and the linkers there, that part of the tool chain was structured, and you guys didn't change that. I double checked this to make sure, but neither of you decided to build a language where the linker is out of the picture and you're composing executables in a different way. And neither of you decided to go with the JVM route and say, you know what, my binary format isn't even defined by the CPUs or by the operating system. Like, I want to do my own thing. So I'm curious if that was a thing you thought about a lot, or if that was just like a thing that you decided was what your language was for. Was there a good reason why you had to do it that way? Would you have liked to avoid the object file linker story, but you didn't for some reason? Tell me a little bit about that.
I used a lot of languages before writing Zig, and my goal was always on the end product. So if the language accomplished what I wanted, it was good enough, and if it couldn't, then it wasn't, and I needed to switch. And eventually I just wanted to do more and more powerful things. Most recently it was a digital audio workstation. And for such things like that, you need to access, the devices on the system. You want to use all the CPU cores. You want to be as fast as possible. You really need to write code that fully exploits the hardware. And to do that, you really only have one option, which is to output machine code. So in my mind, I wanted a language that was the most powerful. And so that's where I landed.
I mean, for me, I just wanted an alternative to C and C++, effectively, right? Because I again, same thing for Andrew. But I already kind of knew exactly kind of what I wanted. Like, look, this is the exact thing I want. I've made numerous languages before where they were just like toy ones, or in certain domains, like some of them ran on VM, some of them went down to machine code. It depended on what I was kind of doing at the time. But again, I just wanted something so I could be more productive programming. And that meant I still had to deal with I call it the real world, but the pre-existing stuff. Like, I had to interface with, I'm still going to interface with some of my old C code somehow, or interface with some of the pre-existing libraries, because everyone talks about the C ABI pretty much. When you're dealing with Windows, you're technically dealing with the Pascal ABI, at least that's what standard call means. It's the old Pascal stuff. But then that's it. They're all dealing with this ABI, so I've still got to deal with all those stuff. There's a big whole legacy things. You can't just be like, hey, I'm going to start from scratch and everyone's going to have to deal with my amazing things. Like, that's not even going to work. You're going to have to build your own operating system. No. Like, I have so little time on this earth. I'm not trying to do that as well. So that's kind of why I did what I did. And I wasn't trying to reinvent the wheel. I wasn't trying to, look, this already exists. Just, I'm going to utilize it, okay?
Okay, great. So I think that was kind of what I expected, which was that you both, it sounds like, were more or less just understood that you wanted the kind of language that would would work, and the only way that they could be made to work the way you envisioned was to go through the same paths that get you access to the native layer of computation. Um, so the follow-up question to dig a little deeper is in the C world, the story about this is that you have, C files, and you use the preprocessor to sort of code up your own modularity somehow, and then each C file gets translated into as a compilation unit into one of these object files, and then a big swarm of these gets linked together. And modern C programmers have somewhat, some of us have transitioned to the Unity build where you say, you know what, let's not have the linker do so much work. Let's just put all of our code. Let's use the preprocessor to just package all of the source code into one unit. That way there's not anything for the linker to do. Or if the linker is doing anything, it's because there's like one function we want to have on optimized while everything else is in debug mode. Or, we want to split the compilation parameters a little bit. And I'm curious, to what extent did you play with that, and what did you land on as your preferred way to package up compilation units? Or how do you relate source code to compilation units to object files? And it was, how important was that in the design of your languages?
From in Zig from day one, 100% of your Zig code goes into one compilation unit, and that was a great decision.
For Odin, I was going to do a Unity build because I already do that in C. But you can already moment, one of the things I wanted was I was trying to figure out how to do the package system. And this is actually kind of integral to Odin, at least anyway, is that this is nothing to do with incremental building. It's just that each package can be separated into its own module unit, literally its own translation unit if you wanted, and then they all get linked to the end. We do that just so we can get around LLVM slowness, pretty much. Because that's literally one of the reasons. But if it was fast enough, we wouldn't care. We'd just do one big Unity build. From what I understand of the history of C and many other languages, the reason why they had all of these different translation units is because of performance. Again, it's trying to compile times. If you can just do this incremental build, like you only build when things change, you're not wasting most time on your time allotted mainframe, right? You've already got the pre-compiled object, which then you can link up at the end, which is kind of why it's called a linker. Mm-hmm. But now I'm like on modern machines. How do I put this? I don't care about that anymore. Mm-hmm. I'm not working with punch cards. I'm not working with mainframes and stuff like that. I don't have time a lot of things. I have a machine which can do that all now. And why not just do it on pass? Pretty much.
C programming language was a really nice sweet spot of engineering at the time. Actually really impressive sweet spot. And the sweet spot has moved, obviously, at this point.
Yeah, and it's not that wasn't a bad thing. It was just very much like the C model itself, which is now how effectively all linkers kind of depend on. It's either going to be the C model or the Fortran model. And they all kind of just went like, yeah, we can have multiple translation units. It's just that's the whole point of linking things together. That's the whole why it's called linker. It's just more of it's that sweet spot where things work. The problem with the C thing is that that's when they started kind of conceptualizing them together. Translation unit is also maybe a library, maybe think. Or maybe it's a single file, and we have to structure it that way as well. And then to some people like us, again, when we learned about Unity builds, it was like enlightening. I'm like, oh, we don't have to do this, do we? Yeah, duh.
Yeah, so I guess what I'm curious about is the object file linker step something you would prefer just didn't exist? Or do you think it's worthwhile? Because one reason I'm going to mostly agree with everything you guys said. I don't do the multiple compilation units either, except, like I said, there are times where, I'm writing a C program, but I'm doing D3D and that needs to be C++ unless I want to do mess the syntax up and mess all the example code up. So I'm like, well, I'll translate that in a separate compilation unit so a different compiler can run it. Or if I'm going to start stitching together, maybe I've got FFmpeg bindings that I want to import into my Zig or Odin program in some way, there's still an interop problem that forces you to play along with, it seems like it forces you to play along with this system. And at the very least, this system is still how we achieve interop. Am I right about that? Or do you think I've got it a little off?
Well, because the previous world exists and you still wanted to deal with the previous world, and I'm using that sense, then yeah, you're going to deal with it. So one thing I did in Odin, which is different to what Zig does, actually, in Odin, you actually define all of your foreign imports together in the actual source code itself, and if it's static or dynamic or whatever the linking is and how these all relate. So the foreign import, the foreign code itself, understands what it's going to link against, and only links against it if you've actually used that foreign code, if you know what I mean. Right? While in the Zig approach, Zig has its Zig build, obviously. Please tell me when I'm wrong, Andrew, please. It's more of the Zig build is more of like, actually, we're still going to define or how we do the linking stuff in that stage rather than in the language level itself. So for me, I don't think the linker should be a separate stage. It clearly is going to still exist, but it should just be part of the compiler, in my opinion. There's no reason why you have to generate the object files and then pass them to the linker. It's like, well, why can't we just generate the object files in memory and do the linking in memory when we need it?
Because we don't have enough memory. Oh, wait, now we do.
Yeah, now we do. There are certain things where we can't, because actually we hit this at work. So I had to fix Odin only ever slightly. It was literally like a 3-line change. Smart linkers exist nowadays, so we still don't have enough memory. So how linkers now work is that because of like big projects like Chrome or LLVM, and in fact we hit this in Embergen not because of our code base, but because of third-party things we rely on. Because the thing linking got so bad, you have to literally sometimes pass files multiple times. Like you have to pass, like let's call it object file A, B, and then you might call A again just to patch in things. And smart linkers will try and optimize this because otherwise you will literally run out of memory, right? Well, you actually will. Chrome and LVM are wonderful examples of this. Oh, bad, so bad. But that's because they are trying to, because how the linking things works are kind of insane. So yes, there are certain things where we don't need to do it, like have to generate a file and then do the link in this way, but sometimes you do. And what I'm saying is, at least for new languages, the first thing is like, well, that's one object. We're all going to put this into memory. Why are we having to put it to a file? The rest of it, the third-party stuff, yes, you still may need to deal with the smart linker benefits to get stupid memory requirements down. But they are kind of still there, and it's just because you've got to deal with the real world problems already existing. Like they are legacy problems. You're never going to get rid of them yet, at least. But that's what I mean. Sorry, bit of a ramble there.
You're all good. What I'm trying to understand, and I'm not sure I'm hearing the answer to, is I know you both support interop with C, and there are like libraries in C that even if I were to adopt one of your languages, I wouldn't want to have to rewrite the font rendering code just to start rendering fonts with them. So I would want there to be interop with the libfree type library, right?
Yeah.
And it seems to me like that's solved at the layer of having a linker that puts object files together. Is that right?
Yeah, that's right.
Yes.
Yes. So I guess what I'm trying to get at here is when you grow up in the C land, you get like these weird notions, as Bill was talking about like what should count as an object file. Is it a library? Is it a file? A source translation? Eventually you learn that it doesn't need to be any of that. But you still have, like I said, one other common example I run into is I need C++ for some of my Windows programming because of their more modern APIs being so much simpler to work with that way. And so that has to go into a separate compilation unit.
So this is where Zig and Odin are very different, actually.
Okay.
In Odin, you can write direct 3D code or direct the entire library, you know what I mean? As if you were just writing C++. Right? Because I made a lot of work to make COM API work stuff. I also did, Odin has direct interop with Objective-C stuff as well. And the syntax will be not the same as direct C, but it will work fine. So you don't have to write it in a different language. You can still write it in Odin, and those things will still work pretty much the same. Yeah? Okay. While in the Zig thing, Zig does have its C import, or it has the C translate, which I prefer much over than the C import myself. That we don't go into that thing. It's just a different preference kind of thing. That is more of you can deal with the C stuff, but then you will struggle with how do you interface with C++ or say Metal or anything like that. Usually you would either have to write it in that other language or you're going to have to write loads of wrappers because again, the C++ stuff at the end of the day, even though there's a C++ ABI, you can still use C-ish and just hack it in and make it work nicely. It's just a lot more work for that library writer. Yeah? So it's just different philosophies. Like I was just like, look, Odin isn't actually meant to be a really simple language in many ways. It is simple, but there's a lot of things like I'm dealing with legacy stuff. How do I deal with this? Like, oh god, COM API stuff. Oh yeah, I'm going to just add this feature in. And I went, oh, that's going to actually help me for Metal as well. Like not just Metal, but Objective-C in general. I'm like, great, there we go. We've got two birds with one stone kind of thing. And that's what I mean. So the problem there, in my opinion, is that there's an ABI thing, which is great, but it doesn't mean you have to write it in the new language, in the old language, and then link it. You could still write it in the new language because it knows the ABI.
I think Alan's point, though, is that if you have actual C++ code, and you
Yeah.
want that code in your binary, then you have to put that in a separate compilation
Yes,
unit.
that is true. That is true. But the reason why I was just bringing this up is more of a, if you've got a pre-existing library and it's huge, let's say it's 10,000 lines. That's not huge, but like 10,000, you don't want to rewrite that into the new language, even if it's just like, oh, you could go line by line and you could do a simple translate. Yeah, hypothetically. But the thing is, if you wanted to write Direct 3D, what you're thinking is like, well, writing Direct 3D in other languages might actually be an absolute pain. That's the reason why I just focused on that one there.
Mm-hmm.
When it's like, well, for Odin, at least I spent a lot of time trying to make that still a very nice thing, and any of the other COM API stuff in Windows at least, like just nice transition. So you can still write it in the native language in Odin, but it will still interact nicely, is what I'm trying to say.
Yeah, gotcha. I think so something that I spend a lot of time thinking about with all this, if I'm going to build a visual programming system, is that I think that it would be a mistake to imagine that I'm going to build an entire program with whatever I create. It seems more likely when you look at things like Houdini, the way they're working is they have a layer of visual programming and then a layer of textual programming. And in that case, it's just going out to Python scripts, I think, or it's going out to several different types of programming language bindings.
Yeah.
But I'm trying to think of, like, if I'm building a native version, is the story about the linker as the way of piecing together a program that is made up of multiple languages still the best way to do that? And is there a good, I guess I'm curious if either of you would had a strong opinion that like the linker should go away, and so this approach to multi-language programming shouldn't be around, or not.
I think it's just oh, sorry, go ahead, Bill.
I was all going to say is I don't think the question makes any sense, because it's like you're saying like, oh, we need to. You're asking, can we link code but not use a linker? Is effectively what I've just heard, and I don't.
Well,
mean that,
you just said
to,
you just said
yeah.
that you can. So you've what I'm getting at is
no. What I said isn't that. No,
Hold
what
on,
I was saying slightly different.
hold on.
What I was slightly different is that what you're saying is like, oh, is still the linker the best way of doing linking third-party code? And my answer was more of a, if it already have to, then yes, then linker is still a thing, because that old stuff still relies on a linker. If you don't need to even write it in the old language, then just write it in the new language.
Right, and I'm asking a thing that I think bisects those 2 points, which is if you want to write a program that uses 2 languages. So I'm making it more generic, so it's going to be crazy, but if I want to write a program with 2 languages, there's a couple ways I could think of doing it, right? One is to use the linker. One is to define separate binaries and have them talk to each other as separate processes. Another is to have separate binaries and do dynamic linking. And another would be that each language needs to put in the effort you put in to like have really clean stories that just make them a seamless mega language somehow.
Yeah.
And so I'm kind of just like polling for opinions on first of all, if you guys have any, because I'm not just assuming you do. I'm just wondering, is there a good reason why multi-language programs are not interesting? Should not be the way that everything in a program should sort of be uniform. And if there is into that response, then what is what do you think the pros and cons are of doing this with a linker? Because I do know some folks who are like, look, the linker is archaic, and all future programming should just eliminate linking if we can get there.
My suggestion is to think of the linker as a means to an end. So if your goal is to use FFmpeg, you're probably going to want to link against FFmpeg object files or static library.
Mm-hmm.
If you're writing your own language or you have a VM, you don't really need a linker, but you also don't have access to FFmpeg, for example. I don't think the linker is really going to give you anything other than just access to code that already exists. That's the way I would think about it.
Okay.
Yeah, that's all I was trying to say either. I was just saying, like, if you need to literally use stuff, legacy things that rely on a linker, then you're going to need to use a linker. If you have your own isolate language, which never actually links against anything, technically speaking, or saying, put it this way, the thing is, you still have to do linking, regardless. This may sound silly. Linking still exists regardless because of how the operating systems work. Like Windows, everything does get default linked to kernel 32, but you still may, let's say if you want to use user32.lib, you still have to link against that, even if they're just dummy things, obviously, most of the time. There's a loads of them where you're still kind of, again, you're patching the bits and doing the reallocations and doing it that way, like what linkers do. I don't think that thing's ever going to go away because of the platforms we're on. And if you want to prefer to do dynamic linking, that's another thing as well, or dynamic libraries in general. That's another benefit as well. But that's in my opinion, to use a DLO of a static library, like a dynamic library, there are different use cases for them, obviously. So I think they're the same problem in the sense that you're trying to link separate pieces of programs together, but at the same time, they are different solutions to a different kind of problem, if that makes any sense.
Yeah.
It's very hard to phrase.
I think the fact that you guys don't have, it might sound like I asked a silly question because the responses the responses I'm getting basically confirm that what I want to do works, because if it wasn't, you would have had a more interesting explanation for why it's a bad direction to go. But it sounds like, the linker is a fine way to do what I have in mind, which is to continue to use existing programming languages side by side with a new thing.
Well, it's not that I can let's say I imagine two brand new languages, right? Two brand new languages, you just want to interface with these two. You wouldn't even necessarily have to use a linker for that, right? Because the trick here is those two languages could actually go down to like a bytecode, and then they merge together. And yes, it's not necessarily a linking in this case. It's literally just like they concatenate together. And that's it. Not even just like moving things around like a linker does. These just go plop. And that would be maybe that is still classed as a linker. Maybe it is. But maybe it's just another step. It's just another linker, just a further few stages up. But that's what I mean is that I don't know. I just think I'm just trying to think of an alternative, and everything I do is just reinventing a linker.
Yep. Okay. Here's a good final question for us to wrap up on. So I've appreciated all of this. I've got a lot of new ideas from you guys, and I enjoyed some of the brainstorming session we did. This is going to be much closer to just a practical advice question, which is I've never written a full-on language before, and I'm not really planning on doing a textual language, even if I do, but I would like to hear what your advice would be to anyone who is getting started. Like not advice on here's how I imagine you going to discover a good language design, but more just the practical stuff of like if you wanted to clone the basics of C and you wanted it to actually execute. Is there advice like grab LLVM, or is it like don't grab LLVM, or what?
Don't grab LLVM. I'm sorry. I'm saying just stay away from LLVM. Like it's like the plague. Seriously, that's the one thing I would say to everyone. Oh, sorry. Yeah.
What is the bag of tricks that you want to get started quickly and painlessly with a language project?
Bag of tricks, for me at least, I would say learn how to do tokenization or lexing, whatever you want to call it. Technically slightly different, but learn how to do parsing and do recursive descent parsing. Don't learn any other kind. It's going to be literally useless to you. If again, I'm talking about textual, obviously. And then after that, learn how to do basic type checking and stuff like that, and learn how to do it. And then eventually learn how to go from your, let's say, typed AST, if you're doing the traditional route, like learn how to do an AST and all that lot. Then go and lower that down. You may not even need to learn the AST. Like a good example of this is, I would recommend people go make a, how do I put this? Either make a Pascal compiler. You won't even need an AST for that, because you can just go top to bottom and output the machine code. So you need to learn how to do that as well. Or make a Lisp and make that run like on a VM.
Let's say specifically that the goal is to compile a native executable. So if my goal is to actually be able to output an executable, you're saying not LLVM. So can you fill in like what is the easy way to day one do that?
Is the goal to learn though, or is the goal to create an engineering project that survives for a long time?
That's a great question. Maybe I would like the answer to both. I think I would like the answer to how to prototype so that I can explore, and then also what is the long-term sustainable, or not the long-term like robust way to do this.
For me, I would just say, how do I put this? I would say first just go straight to machine code. And I don't mean that as a joke. I was going to write a little article series myself once explaining how people can do this and just literally write directly to an exe. You don't even need a linker. And just do that for a basic little language. Again, a Pascal. And then you could go step by step and then start iterating to show how you'd improve this. And then eventually it's like, oh, you've now got this machine code thing. Now we're going to add an intermediary stage. So then we can turn this intermediary representation to this. and then build up from there. The reason why I'm telling you never use LLVM is just because how bad I know LLVM is. And I have lost too much hair to that. And I would never wish that upon anyone. Really wouldn't. And I know it sounds like I've got trauma. I do. But it's just more of a, if you've never made a full-on thing, I would start with a learning thing. And then if you go into the actually making like a thing that lasts, make sure this is your 10th language before you do that. And I don't mean that as a joke. I've gone through, probably 20 languages before I did Odin.
Okay, gotcha.
And even when I was doing Odin, I got like, within about 3 months, I probably got 60, 70% of the language done. And then that last 30% took me the rest of that 8 years. Because there's a lot of things which sometimes once you get into that thing, it's like, oh, actually, this is actually hard. And sometimes it's not a problem. You have to do a hell of a lot of research, figuring out, and also try and figure out things, what people want. Because a lot of the times when I'm doing design, I'm actually asking people, hey, what problems are you having? What are you trying to do? What are you trying to solve? And then you have to get a lot of feedback back, because if you're just making it for yourself, you can do whatever the heck you want and you'll be fine. But if you're doing it for others, the engineering problem, you'll be surprised at actually what people need and want. And you go, oh yeah, I never even thought about that because I've never actually encountered it myself in this real world. Like I never did any kernel work whatsoever in my life. And then people said, yeah, can we do some of the kernel stuff? I'm like, oh yeah, okay, I'll have to implement this, won't I? And that's what I mean. I mean, do not even start off doing an engineering thing last to begin with. Make so many different languages and different paradigms, not just C's and Pascals or Pythons. Try making a Lisp, try making a Forth, try making an ML style one. Literally, because you'll be starting realizing they all have different ways of structuring how you organize your compiler. Because the hard bit in the entire compiler, if you ignore optimizing like your back end, it's the core middle bit. It is that checking stage, the semantic checking stage. That is where the meat and potatoes of the entire compiler is going to be. And you'll learn how to structure it, how to give better error messages, how you actually meant to do that kind of thing. And I know you already know how to do tokenization and parsing. You probably can do it in your sleep. But it's that middle stage, which is it's hard. That is actually really hard to do. And actually make it decent, get extra information out, and actually do it. Like one thing I also will regret with Odin is I designed Odin so it was like just allocate never free, just do it as a single pass. And the Odin compiler itself is not usable as a library. Really. In a sense, I could make it as a library and it's like, okay, I've compiled it and now I can read it, but I can't call back and forth to it. Yeah, if that makes any sense.
Yep.
I have a slightly different suggestion. It's kind of a piggybacking on. So, I know, Alan, you said that the goal, the premise is that you're trying to target machine code, but I think regardless, my suggestion would be to target something simpler like WebAssembly first. Get your front end working with a WebAssembly backend. And then you can run the code with a third-party WebAssembly interpreter or recompiler. You can even get machine code out of it if you want. And then that's kind of like your training wheels. And then once you're ready to graduate, you can even do optimizations before you switch the backend, but it gives you a chance to choose what you want to work on. And then at some point you can go in after you've gained the experience, working on a compiler for a while, then you can go in and write your lowering to machine code instead of WebAssembly, and it'll be pretty similar, just a different language.
Mm-hmm. Okay. Yeah, I appreciate that. So while we wrap up, can you each, Andrew at first and then Bill, give us just like a site where we can follow you or see if you've got any blogs or events that people want to continue to get information from you, where they can go to find that?
Yeah, I'll go real quick. My homepage is andrewkelley.me. That's a Kelley on my last name, and it has an RSS feed. So if you like that, I also have to plug Zig Software Foundation. It's a nonprofit, so we get our money from donations. Any money is appreciated.
Yeah, you can find me again on my website, gingerbill.org, or you can find me on Twitter or YouTube. You probably find it under the name Gingerbill again. There's also the Odin website and the Odin Discord are very useful. And again, a good way I'm going to plug it as well. The Odin like project in general, we do again donate. It's always great. It helps actually help people, actually pay people to develop on things and generate new things, and not just programming, but artwork and articles and many of that as well.
All right, awesome. Thanks, guys.
Thanks, Alan.
Hey,
Take
thank
care.
you very much, Alan.